Good morning, students. Now I am going to discuss another topic in organic chemistry, that is displacement of electrons in organic compounds. Nothing but displacement methods. Here four methods are present. They are inductive effect, mesomeric effect, or resonance effect. Both are same. Electromeric effect and last one hyperconjugation. All are very important. First one, inductive effect. What is inductive effect? See, in this case, the displacement of sigma bonded electrons, moves towards more electronegative atom and causes polarization. Polarization means both positive charge and negative charges are present in a molecule. That is called polarization, is called inductive effect. That means due to transfer of sigma bond electrons moves towards more electronegative atom in a given organic compound, then polarization causes. That is called inductive effect. This is two types. One is plus psi effect, that means positive inductive effect. One more is negative inductive effect, nothing but minus psi effect. Now we have to discuss about these two. See, plus psi effect. The displacement of sigma bonded electrons is away from the group is called plus psi effect. Displacement of sigma bonded electrons away from group, that is called plus psi effect. Suppose these are electron donating groups. OH, that means alkali group, amine group, alkyl group, analkyl group, acetamide group, ether group. These are what? Electron donating groups. That means they donate electrons to given organic compound. Suppose if the given organic compound is like this. I didn't mention here hydrogens, I just mentioned only number of carbons only. To this given organic compound, if alkyl group is attached, this is alkyl group, if it is attached, what is the role of alkyl group? It donates electrons to given organic compound. First it donates electrons to this carbon, then the electron density present on this carbon is more, then those electrons transferred by this atom to another carbon, then this carbon donates those electrons to this carbon, then this carbon donates those electrons to this carbon. Like that, what happened? These are what? Sigma bonds. That means transfer of sigma bond takes place throughout the chain, because this group donates electrons. So what happened finally? Throughout the chain, electron density increases. Nothing but number of electrons increases. That is why it is called plus psi. Plus means increases, which increases number of electrons. That is why it is called plus psi effect. So if electron donating groups are present in given organic compound, that comes under which category? Plus psi effect. We have to understand like that. Next, minus psi effect. The displacement of sigma bonded electrons moves towards the group. In this case, those electrons moves away from the group. This is the group. Electrons are not moving towards the group. Here electrons move away from the group. Here electrons move towards the group. That is called minus psi effect. See, this is the example. Suppose if halogen is present, halogen acts as what? Electron withdrawing group. Fluorine, chlorine, bromine, and those are called what? Halogens, because they have more electronegativity compared to carbon. So they gain electrons from carbon. Then this carbon gains electrons from this carbon. Then this carbon gains electrons from this carbon. Like that, what happened? These electrons moves towards halogen. That effect is called minus psi effect. Why it is called minus psi effect? Throughout the chain, electron density decreases. So these are the examples. Which examples? These are the electron withdrawing groups. Whenever electron withdrawing group is present, then it withdraws electrons from given organic compound. So electron density decreases. That comes under minus psi effect. That's it. Next, it is a short range effect. This is very important point. That is, the compound contain 4 carbon atoms. That means what? If you see this example, then you get an idea. See, here 4 carbon atoms are present. If electron donating group is present here, this effect is more on this carbon. Compared to this carbon, the effect of this alkyl group is somehow less. Compared to this carbon, the effect of alkyl group is somehow less again on this carbon. So like that, the effect slowly decreases because distance increases. So this effect up to 4 carbons only. This effect is up to 4 carbons only. That is why it is called short range effect. Next, it is a permanent effect. Permanent effect means if electron donating group or electron withdrawing group is present, then they donate electrons or they withdraw electrons continuously. That is the meaning of that point. Next, mesomeric effect or resonance effect. Mesomeric effect, one more name is what? Resonance effect. Here the definition is what? The displacement of pi electrons. The displacement of pi electrons caused by an atom or group in the conjugated system. Conjugated system, that means if double bonds present in alternative position, that is called conjugated double bond, single bond, double bond. That is called conjugated system. That is called mesomeric effect. Here also this is two types like inductive effect. They are plus M and minus M effect. See, here the displacement of pi electrons is away from the group. Like displacement of electrons, sigma electrons is away from the group in case of plus A. That is called, here also same phenomenon takes place. These are the examples. That means if electron donating groups attached to conjugated system, what happens? They donate electrons. Then between this carbon and halogen, double bond is present. Then electron density is more on this carbon. Immediately that carbon donates these electrons to another carbon. Then double bond is present between these two carbons. Then the electron, then immediately this carbon donates these electrons to another carbon. That means what happened? Transfer of pi electrons takes place due to donating of lone pair of electrons. By electron donating groups. So here also same phenomenon takes, but what is the difference here? Here we should take conjugate system, there we should take saturated system. Here pi electrons transfer takes place, there sigma electrons transfer takes place. That is the only difference between plus M and plus I. Similarly, in case of minus I effect, if electron withdrawing group is present, then transfer of pi electrons moves towards electron withdrawing group. See, moves towards the group. That is called minus I effect, just like minus I effect. I hope you understand. Next, here one important point is that is halogens. That means chlorine, bromine, iodine, fluorine. They shows minus I effect. See, in this case, halogens came under minus I, but they show plus M. Here plus M. In case of plus M, this is the one of the example. So, in what you have to understand, when halogens attached in saturated system, they withdraw electrons. That means which electrons? Sigma electrons. But when they attach to conjugated system, then they donate electrons. You should understand that point. When they donate electrons, then it shows plus N. When they withdraw electrons, then it shows minus N. That's it.